The next strategy is grouping. And we use the strategy when there are 4 or more terms in the given polynomial. So for our purposes, we're only going to see polynomials with 4. If you take college algebra, you will probably see some that have 6 and more. But that's the strategy that you want to use when you have 4 or more terms. Now, with grouping, it's exactly what it says it is. We're going to group together terms, and we are going to be looking for a greatest common factor. So in order to group, you split your polynomial down the middle, and I like to use an index card and just cover up the second half of the polynomial, focus only on the first. And in the first part of the polynomial, we have a greatest common factor of 2x. Both of these terms have a factor of 2x that we can take out, so 2x is the greatest common factor. 6xy divided by 2x leaves 3y. 10x divided by 2 leaves plus 5. We're going to do the same thing with the other side of the polynomial. So, is there a greatest common factor that can come out of negative 3y and negative 5? So, a hint is this. Anytime that we see this leading coefficient as negative, it would definitely be wise to take out a negative. And in this case, the only thing we can take out is a negative 1. So negative 3y divided by negative 1 leaves positive 3y. Negative 5 divided by negative 1 leaves positive 5. And that is exactly the same factor that we had in the front. So it's a binomial common factor like we saw in the previous video. We can factor it out as the greatest common factor. So 3y plus 5 comes to the front, and if we take 3y plus 5 away from both of those terms, what are we left with? We're left with 2x minus 1. 2x minus 1. And you can check this very quickly just by using a double distribution. I will do this for us quickly. 3y times 2x is 6xy. 3y times negative 1 is negative 3y. 5 times 2x plus 10x, 5 times negative 1 is negative 5. We can compare the beginning and the end. It's a different order, but it is indeed the same exact expression. So those are the correct factors. We're going to do it again on number 2. Split down the middle. And just like I did over here, keep that sign with its term. This time we have a plus there, so not as big of a deal as when we have a minus. So we're going to look at the first 2 terms. The first 2 terms are 4x cubed and negative 14x squared. We have a greatest common factor of 2x squared. So when we take out 2x squared, 4x cubed divided by 2x squared is 2x. Negative 14x squared divided by 2x is negative 7. We want to look at the other side. Positive 14x minus 49 has a greatest common factor of 7. Positive 7 is coming out. 14x divided by 7 is 2x. Negative 49 divided by 7 is negative 7. Once again, we have a binomial greatest common factor. Bring it to the front. What's left? 2x squared plus 7. That is factoring by grouping. Next strategy is everyone's favorite, the guess and check. Guess and check is a very valid strategy. We do this often when we have a difficult mathematical scenario. We might make a guess and see if that particular guess makes sense when we plug it back into a problem. So guessing and checking is a valid strategy. And note the word and. And is not or. And is first the guess occurs and then a check will occur to validate or disprove your guess. So it's an imperative. It's not optional. The best option when the leading coefficient is not 1. If your leading coefficient is 1, then you don't have to guess and check. You can just look at the constant on the end and basically find a pair of factors that has the sum of the middle term. So, number 1, 18x squared minus 3x minus 10. So we are going to focus not on the middle term, but we are going to focus on the first term and the last term. So we need a pair of factors for 18. So the factors for 18 are going in those first spots. So factors of 18, we got 1 and 18, 2 and 9, 3 and 6. So we're going to make a guess. Let's go 2 and 9. 2x, 9x. So 2x times 9x is where 18x squared comes from. Now, we're going to use the negative 10 and put in a pair of factors for negative 10 in the last spots. So why don't we choose 5 and 2? And we can put a plus here and a minus here. Now, I have made a guess. That guess is going to be followed by the check. Now, right away, here's something I can see. My inner terms, 5 times 9 is going to give me 45, which is way far from negative 3x. I can already see this isn't going to work. But let's go ahead with a full check, and then we'll make a better guess. So, 2x times 9x, 18x squared, 2x times negative 2, negative 4x, plus 45x, minus 10. So we don't get a negative 3 in the middle, so this doesn't work. Now, I just made a guess that didn't work because it's okay to make a guess that doesn't work. Don't be nervous about writing down a guess. Just make a guess and check it. If it doesn't work, put a line through it and move on. Let's choose better this time. So negative 10 is definitely a 5 and a 2. It's almost never the 1 and the 18 or the 1 and the 10. It's almost always something a little more towards the middle. Now, 18. We tried 2 and 9. 9's a large number, so when it mixes with the 2 or the 5, it takes us somewhere far from the 3. That's why the 3 and the 6 make more sense. So, if we put a 6 here and a 3 here, this is going to give us 12. And this is going to give us 15 when we do our distribution. And a positive 12 and a negative 15 is where we're going to get this negative 3 in the middle. So we need a negative 15, I'm going to make the 5 negative, and a positive 12, so I'm going to have the 6 and the 2 be positive. So this is a much better guess. Let's give it a quick check. 6x times 3x is 18x squared. 6x times 2 plus 12x, negative 15x, and a negative 10. And there is our negative 3x in the middle. These are the factors. So here we've got number 2, and I'm pointing out the negative sign up front. And whenever we have a negative sign up front, we need to first factor out a negative because we want our leading coefficient to be positive. And if we have 90, 57, and 15, they're all divisible by 3. So let's take out the 3 first. It is the GCF. So negative 90 divided by 3 is 30x squared. Positive 57x divided by negative 3 is negative 19x. And then 15 divided by negative 3 is negative 5. There we go. So now for 30, probably not 1 in 30. Remember to bring down that GCF. For 5, 5 is easy because 5 is a prime number. It's only 5 and 1. So let's think about this. If we need to get a 19 in the middle and we have 30, our options for 30, not 1 and 30, probably not 2 and 15, either 3 and 10 or 6 and 5. Let's try the 6 and the 5 and see what happens. I think that's a winner. 6x, 5x. Remember, it's these two factors that give us the first product, and it's these two factors that give us the last product. That's true every single time in guessing and checking. So from here, this is going to give us 6, this is going to give us 25, and 25 minus the 6 is what will give us the negative 19 in the middle. We need our 25 to be negative, our 6 to be positive. Once again, let's give it a whole check here. Remember, negative 3 is just coming down. We know that it's the GCF. So 6x times 5x is 30x squared. 6x times 1 plus 6x, negative 25x, and a negative 5. There's our negative 19x in the middle. So those are our factors. That is factoring by guessing and checking.